Hi guys, Assalamualaikum warahmatullahi wabarakatuh, and good good morning, yeah. So today topic is computer integrated manufacturing (CIM). So I make a review for this topic by this video for you all to do a self revision. Alright, I hope you already learn the same topic, and then you can now be able to understand the concept of the integrated manufacturing system. And then I also hope you already understand how to distinguish different concept of computer integrated manufacturing. Alright, so what is CIM actually? CIM is a computer integrated manufacturing. They come from word CIM, CIM. So C refer to computer. Computer because in the CIM we use a machine that can be enable the tooling system. For example, we have a CNC machine. They will have a automation system for tooling changing. So they have enabling tool. Information flow, they can have a computerized system to info the flow from the control system to the tooling controlling system and the machining sites. So they have information flow inside the process, and then information management. They have using computer to manage the information. That's why the wording of computer there. So they take the C capital letter for CIM, and then I is integrated. So they have integration and versus interfacing. So integration between the, for example, they have tooling system and then machine. For conventional, for example, for the milling process, they just do a mill process to remove the material. But when to have another layer process or second layer process, they need another tools. So they need to make integration between tool handling and then machining side. And then after finish the process, so they make also integration with the robot system, interfacing between the PLC programming and with the robotic programming. So there is integration and then interfacing in between programming language interface, because they have different interfacing there. So the robot will pick up the material from the machine and then put as a finished product to the conveyor. That is the integration system. They integrate all the process in the one integrated system. Yeah? And then they share the information. They share information from the tooling system, machining system, and then the work pick and place system. So that, for example, robotic system, they're sharing those information. That is integrated. The I for integrated, and then M is manufacturing. The wording M for the manufacturing, because they involve for the production control, production scheduling, production design, process design, product design. So all related to the manufacturing to using this integrated system from the computer integrated system and then to produce in the production. This all involve computer integrated manufacturing. So definition seems a technology, tool or method used to improve entirely the desired and manufacturing process and increase productivity, using computer to help people and machine to communicate. Architecture for integration of multiple technologies through computer, linking each individual islands of automation to closed loop to a closed loop business system. So they have for integration between for individual island. They have this process, different process for the work cell, for example, they have an island for the process of automation. So they link each other using CIM. And the integration of computer-aided design, automatic material handling, robotic process technology, manufacturing planning, control, computer-aided quality control, computer-aided manufacturing, and focus of the computer as a center of control of the entire factory, starting from the computerization of the fabrication and assembly process to the information flow for production. Okay, that is a definition about CIM. So can simplify as a one, computer integrated manufacturing. That is a manufacturing approach of using computer to control entire production process. So as I said just now, the computer very given the main part to CIM because they're using computer to control all the production process. So before the late 1790s, before that, the computer is not the processor, the processor of the computer, the processing, the data processing is not much, so they have a limited to use a computer system. After 1790, after that the computer increasing, they have Intel's, they develop the CPU, their process become faster, they can process a lot of data. So that's why now they have a machine learning to train the machine to react as like people. The robotic is different because robotic, we need to teach robot and then the robot will follow what we teach. But machine learning, we just teach some algorithm, they can learn by itself, refer to the trend what we teach. So they will use the sensor system to detect and then they can react like a human because of computer processor. So the computers can do a fast calculation of a lot of data. So that's why computer now using in computer integrated manufacturing, they use computer system to control entire production process. And then this integration allow individual process to exchange info with each other and initiate action. So for example, they have different for the tooling, for the machine side, for the material handling, they can change the information between each process. So they can make, for example, after they got the information, the process or the machining for the first layer or the finish, they give the information to the tooling side to enable the tooling to change the tools. So they change the correct tool for the correct process, and then after finish they change the information to the pick and place robotic department or section to say that the process already complete, and then the next action is the robot will come and pick up the workpiece and then to put on the conveyor. That is the integration to allow individual process to give information that to initiate the action for the next process. And then through the computer integration, manufacturing can be faster. So manufacturing can be faster because the less setting time. For example, in the conventional, we need to change the tools, for example, for the CNC machine. So in the process, we need to use five tools, for example. So we need to 5 times to change the tool. So for example, the tooling changing, we need 20 seconds or 1 minute more than, for example. So for calibrations, for setting everything, like we need for example less than 1 second, 1 minute, for example, for one tool. So if we have 5 tools, we need already 5 minutes to do a setting, adjustment, everything like that. But if we use system integration for using CIM, the process can be faster, can be more faster, less error, because this tooling system already did by automatic system by tooling changing. So they just do a rotation and then pick the right tool within a second, and then no need to do calibration because the workpiece already there, the setting of the tool already there. So they already do calculation automatically for parameter setting, everything like that. So they can be less error prone, although the main advantage is the ability to create automatic manufacturing process. This one will be can be done as a fully automatic system. So with CIM, we can do a full automation process. And then a typical CIM rely on the closed loop control process based on real-time input from the sensor. So like I said just now, we allow the exchange info from each individual process or station. So how to change it, how to give the info, we use a sensor to do a closed loop process based on real time. So on the real time, they give the information, and then at the same time the process will initiate the new action for the next process. Okay. And then CIM encompass the entire range of product development and manufacturing activities, with all the function being carried out with the help of dedicated software package. And then data required for various functions are passed from the application software to another in a seamless manner. For example, the product data is created during design. So in the CIM, using SolidWorks, for example, when we design something, we can create the product data for that particular design, and then we can automatically send the software or CAD data to the machine to produce the part what we design, and then we can have a real-time monitoring system for that product, because we already create the product data, and then the product data can be monitored by the sensor at the machine during the process, and this data has to be transferred from the modeling software to the manufacturing software without any lost data. So this one very useful data transformation, because we can use this modeling data. We can model, we can make a simulation after we design something, and then we can see either we use the correct tools or not, the speed, the path. So we can avoid the broken of the tools during the process if the process is not right. So that's why after we run the modeling or simulation, we can transfer the ready software to the manufacturing software without any lost data, and then the process can be done after that, after the data transformed to the machine side. And then CIM use a common database wherever feasible, and common tag to integrate data, manufacturing and associate business. And then CIM reduce the human component of manufacturing, and thereby relieve the process of its slow, expensive and error-prone component. Okay. So the term CIM is both a method of manufacturing and the name of the computer automatic system in which individual engineering, production, marketing and support function of manufacturing enterprise are organized. In a CIM system, functional areas such as design, analysis, planning, purchasing, cost accounting, inventory, control and distribution are linked. They all are linked through the computer, which factory floor functions such as material handling, management providing. So management, when they provide the information. So they link all this information with the all those sections using SIM. For example, in the design side, they design some part to produce at the production site. So they link all the design data, CAD data with the and they transfer to the manufacturing sites, and then they link also with the material or warehouse department, control department of the material handling. When they need that material to do produce the production in production line, the material handling like a robotic AGV will pass over the material, and then they provide the costing department, finance department to see the cost of the productions, and then the management side like manager side, production engineering side to see the new models coming, the involvement of the design to analyze. They will do they link each other, and then we do automatically at the real times using the SIM. SIM also encompass the whole law of enabling technologies, include total quality management, including total quality management, business process re-engineering, concurrent engineering, workflow automation, enterprise resource planning, and flexible manufacturing. Like concurrent engineering, they need they relies on SIM a lot, because when they get the information from the customer, they will do the engineering process together with the marketing, with the production side, with the procurement side, with the engineering side, to see whether the process can be conduct or can be do at the same line or same production line, or need some improvement to make sure the order they will fulfill the order by the customer. And then a distinct features of manufacturing today is mass customization. This implies that through the product manufactured in the large quantity. So like I said just now in the previous topic, we have a high volume mass production. So when we do automation with the SIM, we can make a large quantity production with less minimum setup time, less errors, and then can produce more quality product, and then can increase more profit. And product must incorporate customer specification changes if they have some requirement for a specific change, and then can be specified to satisfy the diverse requirement of the customers. So we can easily can change new models, new requirement from customers. Alright, in this, and the last class I already showed this video, so you can play back again using my slide to see that video. But for the thing, the challenge in the manufacturing, they have always have these three things together to see for quality, cost, and delivery time. So these three elements, three factors need to compromise to make sure the quality is higher, the higher quality product to meet the requirement from the customer. We need to fulfill the standard, the ISO standard, quality standard, whatever standard we follow, or we need to make sure this is the first one, the top, the quality. But we need to control the cost at the lower cost. For sure, when we think positively, if we want to make a better quality product, we need to invest more cost, But in this manufacturing, this is always become a challenge to make sure the cost, to reduce the cost with the high quality and to meet the delivery time. Uh, to produce the high quality product, actually we need more time to produce with the high cost, with the more time, but we need to face this challenge as an engineer to make sure high quality product can be produced with the lower cost and low with shorter delivery time. Three distinguished components. So as a method of manufacturing, three components distinguish CIM from others manufacturing methodology. So these three components will make different from others manufacturing methodologies. So mean means from data storage, retrieval, manipulation and presentation, mechanism for sensing state and modifying process and algorithm. These are three component. We have number one is data, regarding the data storage, retrieve, manipulate and presentation, because we use computer, so this is related to means for data storage. And then mechanism for sensing, so they have mechanism for sensing state and modify process. So in the CIM they have this element, sensing, to make adjustment, to make automatic adjustment or automatic action to the next process. They use what? They use sensor, and then process data from computer, data, sensor and algorithm. Algorithm is the what is algorithm? Algorithm is the rules, the rules they make in to run the process automatically. For example, the simple rules: when this product finish, they will send the information to the robotic system, and then robotic system know the process already finished, and then they will start moving to take the part from that machine and then put in the conveyor. So when the robot take, that is the what rule number 2, when the robot take the part from the machine, so the machine will acknowledge that the robot already take the part by the sensor, and then the machine already empty and then ready to receive another new material to start another process. That is all the information given by this sensing and then processed by computer data, and then using the rule algorithm. So normally when you learn C language or basic programming, they always use the rule for the judgment, like this one. If no, yes this one, no this one. So there is a rule, they need to make a judgment in this triangle. So yes and no is a algorithm rule. So this is a method to distinguish from others manufacturing methodology. For CIM they have using these three components: computer, sensor and algorithm. So benefit using CIM, they have a benefit using CIM. So one, creation of the truly interactive system that enable manufacturing function to communicate easily with other relevant function unit. So interactive system, so they will make a system can be interactive. And then number 2, accurate data transferability among manufacturing plant or subcontracting facility at implant or diverse location. So accurate data transferability. So I said just now we have a section, a drawing section, for example. They make a system for the design for the part, so they will convert the CAD data and then transfer the data to the manufacturing side for the production side. So they will give the accurate data transferability among the manufacturing plant. Number 3, faster response to the data change for the manufacturing facility. For of course in the CIM, they're using the computer processing system to make a process or to make action faster and more flexibility. When we receive the information from the sensor in the machine, for example, they can process immediately, just in second to make process faster due to data changes for manufacturing flexibilities. And then number 4, increase flexibility towards introduction of new product. So CIM also can increase flexibility. So if we have a new product, we can make a new drawing faster, can give the CAD drawing to the production more faster. So there is a how, and then we can get also information from the material side more faster. So there is all can increase the flexibility towards introduction of new product. And then improve accuracy and quality in manufacturing. So in production line, so when we use CIM, we can improve accuracy and quality. For example, in the previous example I give for tooling system, when we reduce the limitation of changing tools manually, we use an automatic tooling system, so we can reduce the errors, the accuracy of the machine to remove the material chip from the material. So we will give the accurate as a drawing, so with automatic tooling changing system, and then no need to do a setting, parameter setting, and we also can do in the within a second for the tooling system. So this all can improve accuracy and quality in manufacturing or machining. And then improve quality of the product itself. So of course now you can see we have 6 axis CNC machine, 9 axis CNC machine. Why? Because we already have a tooling, we enable tooling control system automatically, so we enable that. So with that, we just design the axis for the rotation of the workpiece inside the machine. So instead of the XY axis for the CNC machine, we have designed rotation, pull and push, that is what XY axis, and then we add the theta and theta for the angles. So there is a rotation between the X axis, Y axis, and Z axis. So we can improve from the 3 axis to the 6 axis, and then we can also make the tools part rotate for the angle of tooling. So before that, maybe the tool only Z axis just go down and up. So nowadays they can rotate along the axis, like Z axis they can rotate to the rotation along the Z axis. So we can improve our quality of product, because we don't need to do setting anymore. Because when we do a setting, of course we need to do some calibration of the workpiece. So workpiece setting is very vital or particular for the CNC machine. So when we use a CIM, this is very good, because we can improve quality of the product itself. We can improve the quality of product, and then we can control the data flow among the various units and maintain of a user library for system-wide data. So of course data flow amount of various unit we can monitor, we can using on the maintenance side, we can use whatever, because we already have data. So all data we can store inside the library, and then we can take it back when we want to use and in any process. And then reduction of lead time, which generate competitive advantage. So reduction of lead time. So this one is very good, because for the high quality, we need to we have challenge to make the process shorter. So with CIM, we can make more process faster, and then more quality product, and then we can produce a lot of part within hours, within days, within months. So of course we can gain more profit. So the cost of per product become more cheaper. So we can give the high quality product with the low cost, and then with the shorter lead time. And then streamline the manufacturing flow from order to delivery. So we can streamline manufacturing flow. So we can see from the ordering side, from customer, from the engineering side, production side, material control department side, marketing side. So we can streamline all those information. So of course from the warehouse we can deliver to the customer based on the requirement order from the customer, also through the marketing section. So there is all those information, the manufacturing flow can be streamlined from starting until the end. So evolution of computer integrated manufacturing, they have evolution, because CIM is considered a natural evolution of the technology CAD/CAM, computer aided design and computer aided manufacturing. When we have a computer aided design, for example, that's I give already explanation. When we design something using the CAD, so before the conventional process, we need to print out the drawing, and then we need to go give to the production site, and the production site go to the machine, and then see the drawing, and then think how to fabricate that drawing, to translate the drawing to the machine. They use the G code to setting the G code, like robotic programming. It just put the coding for the tools changing, for tool moving, for machines, for the process, using all the code. But when we use CAM, computer aided manufacturing, so from the CAD design, we transfer all this data, CAD data, we can upload to the manufacturing site. So that's why this evolution is a natural process, because when we have that one, we have CAD designs. We can automated design system for the design process, and then we extract all those data, and then using in the manufacturing, there is natural process, that integration between CAD and CAM. So they will contribute a lot to do a next process in terms of the machining side. They improve all for the changing, using sensor, everything. So they will integrate all, not only one machine, they integrate with the others machine, like conveyor system, like robotic system, like other system using the sensor. So this is evolution, is considered a natural evolution because of integration from the CAD and CAM. And then Massachusetts Institute of Technology, MIT, USA, is credited for with the pioneering the development in the both CAD and CAM. So they use this in the MIT. They start to do or initiate this process, and then the need to meet the design and manufacturing requirement of the aerospace industry after the Second World War necessitated the development of this technology. and then the manufacturing technology available during late 40th century and the early 50th century could not meet the design and manufacturing challenge arising out the need to develop a sophisticated aircraft and satellite launch vehicle. So like I said just now, that is natural process when we can develop the system using computer, and the computer computational level become upgrade to can process more data, so that there will be more sophisticated part can be developed, can be produced by this manufacturing technology. For example, in aircraft and satellites, they're using a lot of sophisticated product or part. So that's why there is a challenge, that is a challenge arising out to develop or to fulfill this need. And then this prompted by US Air Force and to approach MIT. So this need we have for aircraft requirement and satellite launch vehicle requirement, for example. So the US Air Force approached MIT to develop suitable control system. They use some motor to control program technique to make a machine move automatically for machine tools using electronic control. That is the first machine control automatically using electronic control. The digital manufacturing, the idea of digital manufacturing was prominent in 1980th century when computer-aided manufacturing was developed and promoted by Machine Tool Manufacturer and Computer Automated System Association and Society of Manufacturing Engineers. So this idea normally promoted by machine tool manufacturer. They want to sell their tools, so they use a tooling integrated system, and they integrated with the existing machine. So they make a digital manufacturing, and then CIM is the integration of the total manufacturing enterprise by using integrated system and data communication coupled with the new managerial philosophies that improve organizational and personal efficiencies. Okay, key challenge, three major challenges. So they have integration of component from different supplier. So this is the most challenge happen right now, because they need some integration, because they have different product, different supplier. For example, CNC machine, they have some famous CNC from Japan, for example, from the Mazak, from other supplier from Japan, for example. And then from conveyor, we use a German technology. Of course, they have different interface there. And in robotic, we use German technology for KUKA robot, for example. So to mesh all these CNC, conveyor, and robotic system, we need to use to make integration, because they use a different communication protocol, different communication language. So there is a most challenge part to integrate all these components together. So data integrity. So there is also a challenge for data integrity. The higher degree of automation, the more critical of integrity of data used to control the machine. So that is for example, we developed the fully automation system. They have a lot of data consist from the start until the end of the beginning, from the beginning until the end of the line. We have a lot of data, and then we store all this data in the library section. So when we want to move, we want to use with take all this data, and then we use all this data for each section, for example, to control the machine, to control the process inside the line. So the data integrity is very important to store because if we use that data with the error data, for example, we can get the difference output. We cannot get the accurate process, the high quality process. Why the same system says save on the level of the operating the machine? It requires extra human level in ensuring that that there are proper safeguard for the control data signal. So of course, in the same we need have good operators or computer engineer to control, to make sure the data integrity is there. And then we already reduce the operators inside the line by using the operation, by using the automatic control system, but we need to add others in the manufacturing support system, for example, data analysis engineer. And then process control also the most challenge part in the control, because computer may be used to assist human operators. Computer may be used to assist human operator of the manufacturing facilities, but some competent engineer need to see the process which could not foreseen by control software engineer. So in the process control, even we have already software engineer, for example. So we need another engineer to verify, to see the process control. That is all challenge from the company. So we need to find the skill manpower in terms of process control engineer. So this is all three challenge: integration of the component from different supplier, data integration, and then process control. CIM and production control system. So this is a pyramid chart for the process CIM and production control system. So if you can see here, from the production system, they have a product here. From there they have like design, how to design method, CAD/CAM, to produce, to see how to monitoring, to give a right technical data, then to see the quality performance. So to do the calculations of material requirement, load PIC. So this is all support to the production system, to control the production system in the production. They have also production plan to control, to plan, to estimate, to make a planning, and then strategic plan from the market. So all this data will support production system using CIM system. So they link each other from the strategy, production, design, from to production, to monitor, and then to pass back the information to the database, to store the information here to database. So this is all production control system using computer integrated manufacturing. So subsystem in computer integrated manufacturing, they have CIM make full use of the capabilities of the digital computer to improve manufacturing. Two of them are variable and programmable automation. So there is subsystem for the CIM, variable and programmable automation, and real-time optimization. And then computer integrated manufacturing system is not same like layout factory, which would run completely independently of human intervention, although it is a big step in that direction. And part of the system involve flexibility manufacturing, where the factory can be quickly modified to produce different product, or where the volume of the product can be changed quickly with the aid of computer. And then some or all the following subsystem may be found in the CIM operation. And then computer aided technique. Computer aided technique, we have CAD, CAD, computer aided design, computer aided engineering, computer aided manufacturing, computer aided process planning, CAPP, computer aided quality assurance, CAQ, PPC, production planning and control, ERP, enterprise resource planning, and business system integrated by the common database. So like just now I show you the pyramid chart. This all involve this component. So for normally they have two part. You can see here they integrate each other, link each other. For the manufacturing, for the process part, for the process side, they have manufacturing. This one, manufacturing, computer aided design and manufacturing, CAD and CAM. So under CAD and CAM, they have computer, CAD and CAM. Design and manufacturing include assembly, and then they have planning for warehouse, computer aided process planning to handle the material, to plan the manpower, everything in the production line. And then they have quality assurance, quality control. So this is related to manufacturing the product, and then we need to pass all this information to streamline with the control unit, production planning and control unit side. So PPC, and this involve with the manufacturing resource planning, material requirement planning, lot size, time phasing, order release, and management control. This is considered support to the production side. So all these are linked with the computer integrated manufacturing system. The scope, this figure show the scope of CAD, CAM and CIM. So if you can see here, the scope of CIM, they have involved all this one. This is all scope of CIM. But for the CAD, CAM, they involve almost all the scope of CIM here. So from design, manufacturing and control, they involve CAD and CAM. They use design. They provide the CAD data to the production, and extract that data to the planning, how the production can be, what the quantity of material we use, how many manpower we use. They all involved in the manufacturing planning, and then how to control the production from the order from customer. And then they relate with the factory operation. But for the business function, they always use for the enterprise, different from the scope CAP and CAM. They use an enterprise planning, this one, business system integration with common base, and then ERP, enterprise resource planning. So this will communicate also with the factory operation, with the design, with the manufacturing control, to monitor, to get the data, to make sure the production can be run. So computerized element in the CIM system, you can see for in the CAP, normally they use geometric modeling, engineering analysis, design review and evaluation, automated drafting. There is all the element using in the CAD for the design. And then for the CAM, they use in the manufacturing planning and control for the CAM. So in the CAM, normally the cost estimation, CAPP, computer aided process planning, NC, numerical control, part programming, computerized work, MRP, capacity planning. And then for the control, they have process control, process monitoring, shop floor control, and computer aided inspection. So this involve manufacturing planning and control using CAD/CAM. But for the business, they have different scope, and then element for this is order entry, accounting, payroll, and customer billing. This for the business function. Subsystem in the computer integrated manufacturing. Number one, we go for the computer aided design, CAD. So also known as a computer aided design and drafting, CADD, is the use of computer technology for the process of design and design documentation. CAD describe the process of drafting with a computer, providing the user with input tool for the purpose of streamlining design process, drafting, and documentation. CAD output is often in the form of electronic file for print or machine operation. CAD-based software in 2D or 3D CAD program such as AutoCAD or AutoCAD LT software. And then use of computer system to assist in the creation of modification, analysis, and optimization of design. So when we design, we use to use all software. For example, using SolidWorks, we use SolidWorks software to create, and then we to create the design. For example, we want to design this one. We use that software to make modeling, and then do some analysis, and then after do some analysis, we do optimization, and then to evaluate our design, and then we make change for the drawing and then modification, and then we have a final design. That is how we use CAD. And then typical tolerance, we do also tolerance analysis, mass property calculation, and then finish element modeling and visualization analysis. They have this tool. And then for CAE, computer aided engineering, is the broad usage of computer software to aid in engineering tasks. It includes computer aided design, computer aided analysis, computer integrated manufacturing CIM, computer aided manufacturing CAM, material requirement planning MRP, and computer aided planning. So they include all this one. And then computer aided process planning, CAPP, is the use of the computer technology to aid the process planning of the part or product in manufacturing, CAPP. So this is example, we use CAE in term of analysis, use a computer system to analyze CAD geometry. So we can have this part for machine. We use this analyze, and then we can see the color here from our analyzing using the CAD geometry. Allow designer to simulate and study how the product will behave, allowing the optimization. When we make analysis, and then we see the result, and then we can make a modification of the drawing, and then we can do optimization, and then we can produce the part, and then can replace to the actual machine, and then can see, and then can produce the prototype, and then can see the result. Then finish element method, FEM, also one part in the computer aided engineering. We can do a finite element analysis, divide model into the interconnected element to see the analysis. We also have finite element model, FAE, finite analysis model. Finite analysis model also use inside the computer aided engineering, CAE. And then we have number 3 is a computer aided manufacturing, CAM. So it's a use of computer software to control machine, tool and related machinery in the manufacturing of workpiece. CAM may also refer to the use of computer to assist in all operation of the manufacturing plant, including planning, management, transportation and storage. And then primary purpose is to create a faster production process, because in the using CAM, we just have CAD data, we can just transform, and then using this all data, and then can create more faster production process and component and tooling with more precise dimension and material consistency, and we can control the quality of the product. I use a computer system. We can use also computer system to plan, to manage and control manufacturing operation. We can plan in terms of material, manpower, and to control the operation side using the CAM. And direct or indirect computer interface with the plant production resources, numerical control of two machine tools. So we can control, we can enable the tool changings based on the CAD data. We use the right tools, and then we can allow the machine do the tool changings automatically. And then computer aided quality of assurance, CAQ. This is for quality, the use of computer for quality control of the product is called as computer aided quality control, or CAQC. The two major parts of quality control are inspection and testing, which are traditionally performed manually with the help of gauge. So manually we just do a manual operation by gauging or by measure the device in the last operation unit. But with the two major part of the computer aided quality control, the computer aided inspection, CAI, and the computer aided testing, CAT. With the CAI and the CAT, we can perform by using the latest computer aided computer automation and sensor technology to do automatic inspection. And then CAI and CAI and CAT are the standalone system, and without them, the full potential of CAQ cannot be achieved. So this is allow us to make a fully automatic system, because normally for quality is a very important part, but we cannot do, we relies a lot to the manpower, visualize inspection, for example, operator or manpower to see the quality of product. But when we use a lot of sensor to, like camera or auto gauge, to measure, we using CAI, is computer aided inspection and then computer aided testing. So this can be done by automatic system using computer aided quality assurance inside CIM. So the main objective of the CAQC are to improve the quality. So the main objective is to improve the quality of the product, increase productivity, and because we can do inspection more faster, and then we can do the correct measurement for the all product, and then of course we can give more quality product, and then increase productivity in the meantime. And then number 5, computer aided process planning, CAPP. The generative process planning in the advanced generation of the CAD/CAM. This use more powerful software program to develop the process plan based on the part geometry. So based on the part geometry, the number of the part to be made, and the information about facilities in the plant. So computer aided process planning, they involve a lot of planning. So they have information for the part geometry, how many, how size, the quantity, and then the numbers of part, the quantity to be met, order, and then the information of, because the number of the part will be relate to the material will be order, and then the information of the manpower will be planned to do a production, then the information about facilities in the plant. So the information we have in the plant, this facility can produce what model. So all this information store inside the computer at the process planning. So we can do a process planning at because this is at a react as a bridge, act as a bridge between design and manufacturing, and then by translating the design specification into the manufacturing process detail. And so number 6 is production planning and control. So production planning and control is the organization and planning of the manufacturing process. So the name already, planning and control, they involve to organize and planning the manufacturing process. It's coordinate supply and movement the material and labor. So when we know the product order from the customer, we can make a coordination, to organize the material, the levels, to ensure the economic balance, utilization of machine and equipment, as well as other activity related to production. So we can make a just-in-time system. So the right material volume for the right production quantity, and then the right manpower based on order from customer. So this part I will touch again in the just-in-time system for the lean production, based on Kanban system, like pull requirement for the Kanban system based on customer requirement or customer orders. And then production planning control, they also they have 3 stages in the production planning control. Of course, 1 is planning, number 2 operation, number 3 is control. Planning the choice from several alternatives of the best utilizing the available resource to achieve the desired objective. So they plan based on what we have, resource we have. So we do the best option choice to the production to plan the production. And then the operation, of course, when involved the operation, they should perform the operation based on planning what we have, perform according with the details set out in the production plan. We plan and then we perform the operation, and then we control to with the monitoring. We monitor the process, we plan, we operate that, and then we monitor the process what they perform. And then through this we have feedback, and then compare the result from the actual one with the planning, and then we can make a control system to react on based on that one in the real time. Objective of production planning control: to deliver goods and in required quantities to customer in required delivery schedule, to ensure maximum utilization of all resources, to ensure production quality product, to minimize the product throughput time, to maintain optimum level inventory, to maintain flexibility in manufacturing process. So function of PPC, they have routing, estimating, scheduling, loading, dispatching, expediting, and then evaluating. So the level of PPC, they have level here: strategic planning level, tactical planning level, and operational planning level. Long range for the strategic, intermediate range for the tactical, and then short range for the operational. So in the long range, strategic planning is a process thinking through the organization, current mission and environment, and setting a guide for future decision and result. Example: technology forecasting and choice of appropriate technology for the long range time horizon. And then for intermediate range for tactical planning, is done over the intermediate term or medium range time horizon by middle level management. Middle level management, this plan focus on aggregate product rather than individual product. So normally supervisor, production floor, they have a technician, they have middle level management do this tactical planning. And then of course they have also operation planning for short range, generally applied to specific time frame in which specific series in the operation. So in this case, operation planning normally done by operation side. Operators, they can do a very short planning to improve, to do plan, to monitor, and then to see the process can be performed and need to update or not. So they will do in the short range time. And then benefit of the PPC. PPC coordinates all the pace of the production and operating system. And then an efficient plan result in higher quality, better utilization of resources, reduce inventories, better customer service. That is all benefit using PPC. And then limitation of PPC, we also have limitation like function is based on certain assumption of forecast of customer demand, plan capacity, ability, or material itself. So and then employee may resist change in the production level set as production plan. So there is also limitation. So because normally they already familiar with the certain procedure, certain plan. So when they have a new one, they will react a different way. They try to resist changes. And then this process is time consuming. This process is time consuming. So we need to plan, to perform the production, and then to control, to monitor. Third is time consuming when we need to carry out routine and scheduling function for large product also. And then we go for the number 7, enterprise resource planning. So ERP. So integrate internal and external management information. Internal, we have that one, production, CAM system. And then we integrate with the external management information across the entire organization, like finance, accounting, manufacturing, sales and service, customer relation management. So in automate this activity with integrated software application, we integrate all. And then CIM hardware and software. So CIM software comprise computer program. CIM software comprise computer program to carry out the following function. So we use all computerized system to manage, to do management, manage information system, sales, marketing, finance, database management, modeling and design, analyze, simulation, communication, monitoring, and production control. And nature and role of the elements of the CIM system. 9 major elements of the CIM are marketing, product design, planning, purchase, manufacturing, engineering, factory automation, hardware, warehouse, logistics and supply chain management, finance, and management information system. So subsystem in the computer integrated system. So you can see major element here: marketing, product design, planning, purchase, manufacturer, automated work center, warehouse, finance, information. That is major element in the same system. And then from major element we have a various activity inside major element SIM. So marketing, they have CAP, for finance we have this one, purchase we have this one. So all these various activity in the SIM. So device and equipment required. So to do a SIM, we need a device or equipment. Normally in the manufacturing, they commonly use CNC, computer numerical control machine, tool. So this basically they use to do material removal to perform the machining process, and then they also use direct numerical control to control the machine, and then PLC in the assembly line. They have a certain machine to slide in the jig, the workpiece inside the machine. They use a programmable logic controls to make adjustment, sensor, to use a robotic, computer, software, controller, networking, interfacing, and monitoring equipment. So this is a device and equipment required. Yeah, CNC, DNC, and PLC, others, robotic, computer, software, and then technologies for CIM. When we learn CIM, we also we also can relate with the flexible manufacturing system, because in the flexible manufacturing system they have complete line from from material handling until packaging the product, or do a inspection before packaging. That is a flexible manufacturing. Normally they have a fully automation system to run FMS, and then SRS, this one automatic storage system. So for the automatic storage and retrieval system, they can use AGV robot to find out, to take the material from the warehouse automatically, and then put on the AGV, and then bring to the production site. So, and then the AGV will take the finished part and then bring back to the warehouse to storage in the inventory inside the warehouse. That is a SRS system. And then AGV just now, automatic guide vehicle, bring to help to follow the line in the production, to bring the material, to bring the finished product. And then robotic to help material handling, packaging, to do inspection, to carry the gun, to do the assembly process, welding, everything. So we can use the robotic system. And then conveyors to bring the material or product or workpiece from one station, one cell inside the production line, so they can produce the continuous production in the autonomous system using the CIM integrated technology. That is all technology involved inside CIM. And others also, we have lean to reduce the waste. We have lean manufacturing. We learn lean technologies later. So these technologies, development of the CIM. So CIM is the integration process leading to the integration of the manufacturing enterprise, dictated by the need of the individual enterprise. This process usually start with the need. Development of the CIM, flexible manufacturing cell, automatic storage and retrieve system, CAM-based design, etc., are the example of the island automation. Example, a short computer-based automation achieved completely in the limited sphere of activity of the enterprise. This involves data exchange among computer, NC, machine, robot, gantry system, etc. So this is a schematic diagram for CIM. So you can see from design, they do a design process at the engineering development to create the CAD data for the part design, and they conduct the analysis and then do the calculation, everything, and then finally they make a production definition, and then engineering release, and then send the engineering data to the as a CAM data to the manufacturing site from the CAM using CAM technology, and then make a manufacturing for the product. And then in this case they do quality monitoring, production planning, production controls. So they see the productions and then do business and planning, production planning based on orders from the customer. So you can see here the computer and the paper. So all use computer inside this one, and then even we also have a paper to make uh, to print out the document or design. But for sure all data we need to use computer for calculation, for print out all this paper, and then we have a finished product here. So I think that's all from today's topic regarding CIM, computer integrated manufacturing. So next week we will do a process system for manufacturing, like material and technology information flow in manufacturing, product planning and design, and process planning and design. So thank you. Assalamualaikum.